What if everything we've been taught about life and existence is just the tip of the iceberg? Across the vast expanse of the cosmos, there could be civilizations far more advanced than ours, thriving in ways we can barely comprehend. From ancient myths whispered under starlit skies to groundbreaking scientific discoveries that push the boundaries of what we thought possible, the idea of life beyond Earth has always captivated humanity. Today, we're diving into 10 of the most mind-altering theories about extraterrestrial life, ideas that don't just challenge our understanding of the universe, but force us to rethink our very place within it. By the time we're done, you might find yourself staring at the night sky with a whole new set of questions. Are we truly alone, or is the cosmos teeming with life waiting to be discovered? Let's embark on this journey together and explore the mysteries that lie beyond our world. What if the story of life on Earth didn't actually begin here? The first theory we're exploring today, Panspermia, flips the script on everything we thought we knew about the origins of life. This fascinating idea proposes that life didn't originate on our planet at all. Instead, it hitchhiked across the cosmos, carried by comets, meteorites, or even interstellar dust. Imagine tiny, resilient microorganisms frozen in the void of space, surviving the harsh conditions of the universe only to land on a young, fertile Earth billions of years ago. It's a concept that challenges the very foundation of our understanding of biology and evolution. But is there any evidence to back this up? Surprisingly, yes. Take the case of Martian meteorites, rocks from Mars that have been found on Earth, some of which contain what scientists believe could be fossilized microbial life. Then there are extremophiles, microorganisms that thrive in the most hostile environments on Earth, from scorching hot vents at the bottom of the ocean to the freezing, radiation-soaked vacuum of space. These tiny survivors show us that life is far more resilient than we once thought, capable of enduring the kinds of conditions it might face on a journey between planets or even star systems. The implications of panspermia are staggering. If life can travel across the cosmos, then Earth might not be the only cradle of life. It could just be one stop on a much larger journey. This theory suggests that life, in some form, could be scattered throughout the universe, waiting to be discovered on distant moons, planets, or even drifting through the emptiness of space. It forces us to rethink not just where life began, but how widespread it might be. Are we alone, or are we part of a vast, interconnected web of life that spans the stars? Panspermia invites us to consider a universe where life is not a rare accident but a fundamental, cosmic phenomenon. Now, let's shift our gaze to one of the most perplexing questions in the search for extraterrestrial life, the Fermi Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everyone?" This paradox highlights the strange contradiction between the high probability of alien civilizations existing in the universe and the complete lack of evidence for their existence. If the cosmos is so unimaginably vast, with billions of stars and planets, why haven't we detected even a single sign of intelligent life? It's a question that leaves scientists scratching their heads, and one that opens the door to some truly mind-bending possibilities. One of the most compelling explanations for this cosmic silence is the Great Filter Hypothesis. This idea suggests that there's some kind of barrier, a filter, that prevents civilizations from reaching a point where they can communicate or travel across the stars. The terrifying part, this filter could lie ahead of us. Maybe advanced civilizations inevitably destroy themselves through war, climate collapse, or technological disasters before they can make their presence known. Or perhaps the filter is behind us, and the emergence of life itself is so astronomically rare that Earth is a unique oasis in an otherwise barren universe. Either way, the Great Filter forces us to confront the fragility of our own existence. and the possibility that we might be hurtling toward our own demise. But what if the answer isn't so grim? Another intriguing possibility is that advanced civilizations are out there, they're just hiding. Think about it. If a species were thousands or even millions of years ahead of us technologically, they might have developed ways to remain undetected. They could be observing us from the shadows, choosing not to interfere, or communicating in ways we can't yet comprehend. Some scientists even speculate that alien civilizations might exist in forms we can't recognize, perhaps as artificial intelligences or beings that have transcended physical bodies altogether. In this scenario, the silence isn't a sign of absence, it's a reflection of our own limitations. Then there's the possibility that we're simply not looking in the right way. Our current methods of searching for extraterrestrial life, like scanning for radio signals or looking for biosignatures in exoplanet atmospheres, might be too narrow. What if alien civilizations communicate using technologies or methods we haven't even imagined yet? Or what if they're so different from us that their existence is completely outside the scope of our understanding? The Fermi Paradox isn't just a challenge to find alien life. It's a challenge to expand our thinking and question the very assumptions we bring to the search. Ultimately, the Fermi Paradox doesn't just ask where the aliens are, it asks us to confront the mysteries of our own place in the cosmos. Are we alone, or are we missing something fundamental about the nature of life and intelligence? As we continue to explore the universe, this paradox reminds us that the answers we seek might be more complex and more humbling than we ever imagined. What if everything you've ever experienced, every sight, sound, and sensation, was nothing more than lines of code in an unimaginably advanced simulation? This is the mind-bending premise of the simulation hypothesis, a theory that suggests our entire reality could be a meticulously crafted digital construct designed by an extraterrestrial civilization with technology so far beyond our comprehension that it's indistinguishable from magic. It's a concept that sounds like science fiction, but when you dig deeper, it raises profound questions about the nature of existence itself. The idea isn't entirely new. Philosophers have long questioned the nature of reality, from Plato's allegory of the cave to René Descartes' musings on whether an evil demon could be deceiving us. But the modern version of this theory gained traction thanks to thinkers like Nick Bostrom, who argued that if a civilization ever reached a level of technological sophistication capable of creating simulations indistinguishable from reality, it's statistically likely that we're living in one of them. And if that's the case, who's to say the beings running the simulation aren't extraterrestrial? Imagine a civilization millions of years ahead of us, using their knowledge not just to explore the universe but to create entire realities within it. From a scientific perspective, the simulation hypothesis finds some surprising support in the strange behavior of the quantum world. At the subatomic level, particles don't behave like solid, predictable objects. They exist in a haze of probabilities until observed, almost as if they're being rendered on demand. Some physicists have even suggested that these quantum anomalies could be glitches or artifacts of a simulated reality, like pixels in a video game. And then there's the question of consciousness. If our minds are just complex algorithms running on a biological computer, could they just as easily run on a digital one? These ideas blur the line between science and philosophy, challenging us to rethink what it means to be real. But not everyone is convinced. Critics argue that the simulation hypothesis is untestable, a fascinating thought experiment, but one that lacks concrete evidence. They point out that even if our reality were a simulation, we'd have no way of knowing for sure because the creators could easily program us to accept the illusion as truth. Others question why an advanced civilization would bother simulating a universe filled with ordinary humans, suggesting that if simulations exist, they're more likely to focus on beings of their own kind. Still, the idea persists, tapping into our deepest fears and curiosities about the nature of reality. If the simulation hypothesis were true, it would change everything we thought we knew about the search for extraterrestrial life. Instead of scanning the stars for radio signals or biosignatures, we might need to look inward, searching for clues within the very fabric of our own reality. Are the laws of physics just lines of code? Could the universe itself be a kind of cosmic computer running a program we're only beginning to understand? And if we're living in a simulation, what happens when we reach the limits of our Creator's design? These questions don't just challenge our understanding of the cosmos, they force us to confront the possibility that our entire existence might be part of something far grander and more mysterious than we ever imagined. What if humanity is the star of a cosmic reality show, watched by extraterrestrial civilizations who prefer to remain hidden? This is the essence of the zoo hypothesis, a theory that proposes Earth might be under observation by advanced alien beings who have deliberately chosen not to reveal themselves. Picture our planet as a kind of interstellar wildlife preserve, where we're free to evolve and develop without interference, all while being studied by unseen observers. It's a concept that's equal parts fascinating and unsettling, raising profound questions about our place in the universe and the intentions of those who might be watching. The zoo hypothesis isn't just a wild speculation. It's a serious attempt to explain the eerie silence in our search for extraterrestrial life. If the universe is teeming with intelligent civilizations, why haven't they made contact? One possibility is that they're following a kind of prime directive, much like the fictional Starfleet in Star Trek, which prohibits interference with less advanced species. This could be driven by ethical considerations. Perhaps they believe contact would disrupt our natural development or lead to unintended consequences. Or maybe they're simply curious, treating Earth as a living laboratory to study the evolution of life and intelligence, but the implications go even deeper. If advanced civilizations are observing us, what does that say about their motivations? Some theorists suggest that aliens might be avoiding contact to protect themselves. After all, humanity has a long history of conflict and destruction. Would an advanced species risk interacting with a civilization that hasn't yet mastered the challenges of global cooperation or sustainable living? It's a sobering thought. Our own behavior might be the reason we're being kept at arm's length. From a scientific perspective, the zoo hypothesis also challenges the way we search for extraterrestrial life. Our current methods rely heavily on detecting signals or signs of technology. But what if alien civilizations are intentionally hiding their presence? They might be using advanced cloaking technologies or communicating in ways that are completely beyond our understanding. This raises the tantalizing possibility that we're not alone, we're just not looking in the right way. It's a humbling reminder of how much we still have to learn about the cosmos and the potential forms life might take. Of course, not everyone is convinced by the zoo hypothesis. Critics argue that it's untestable, a speculative idea that offers no clear way to prove or disprove it. They also question why an advanced civilization would go to such lengths to observe us without ever making their presence known. Couldn't they learn just as much by studying us from a distance without the elaborate secrecy? And if they're so concerned about interference, why not leave us entirely alone? These questions highlight the complexities of the theory, but they also underscore its value as a thought experiment that pushes us to think outside the box. At its core, the zoo hypothesis forces us to confront some of the most fundamental questions about our existence. Are we truly alone, or are we being watched by beings far beyond our comprehension? If so, what does that mean for our future? Could humanity one day graduate from being the observed to the observers, taking our place among the stars as equals to those who might be watching us now? Or are we destined to remain in the dark, forever wondering what lies beyond the boundaries of our cosmic enclosure? Whatever the answer, the zoo hypothesis reminds us that the universe is full of mysteries, and that the search for extraterrestrial life is as much about understanding ourselves as it is about finding others. What if Earth is the exception, not the rule? While many theories suggest the universe is brimming with life, the rare Earth hypothesis paints a very different picture. This idea proposes that the conditions required for complex life to emerge and thrive are so specific and so rare that Earth might be one of the only places in the cosmos where intelligent life exists. It's a humbling thought that challenges our optimism about finding extraterrestrial civilizations and forces us to consider just how extraordinary our planet really is. Let's break it down. Earth isn't just a rock floating in space, it's a finely tuned haven for life, shaped by a series of incredibly fortunate circumstances. Take our planet's orbit, for example. Earth sits in the Goldilocks zone of our solar system, the perfect distance from the sun where temperatures are neither too hot nor too cold for liquid water to exist. Water, as we know, is essential for life as we understand it, but even this delicate balance is just the beginning. Our planet's stable orbit is maintained by the gravitational influence of a large moon, something that's surprisingly uncommon in the universe. Without our moon, Earth's axial tilt would wobble dramatically, leading to extreme and unpredictable climate shifts that could make complex life nearly impossible. Then there's the role of plate tectonics, a process that recycles nutrients and stabilizes our climate over geological timescales. Not all planets have this feature, and without it, Earth might have become a barren, lifeless world. Add to that the protective magnetic field generated by our molten core, shielding us from harmful solar radiation, and you start to see just how many pieces had to fall into place for life to flourish here. Some scientists argue that this combination of factors is so unlikely that Earth might be a cosmic anomaly, a 1 in a trillion stroke of luck. But what does this mean for the search for extraterrestrial life? If the rare Earth hypothesis is correct, the universe might be far emptier than we'd like to believe. While microbial life could still exist in simpler forms elsewhere, the emergence of intelligent, technologically advanced civilizations might be vanishingly rare. This idea stands in stark contrast to the optimism of projects like SETI, which scan the skies for signals from alien civilizations. If Earth is truly unique, those signals might never come. Critics of the rare Earth hypothesis, however, point out that it's based on our current understanding of life, which is limited to a sample size of 1 Earth. Life elsewhere might not need water, a stable climate, or even a planet like ours. It could exist in forms we can't yet imagine, thriving in environments that would be hostile to Earth-based organisms. This perspective keeps the door open to the possibility that life, and even intelligent life, might be more common than the rare Earth hypothesis suggests. But it also raises another question. If life can arise in such wildly different conditions, how will we recognize it when we find it? At its core, the rare Earth hypothesis doesn't just challenge our search for extraterrestrial life, it challenges our understanding of our own existence. Are we the result of a cosmic fluke, a lucky roll of the dice in an otherwise barren universe? Or is life more resilient and adaptable than we give it credit for, capable of finding a way even in the most unlikely places? Either way, this theory invites us to appreciate the fragility and uniqueness of our planet, reminding us that Earth isn't just a home, it's a miracle. And as we continue to explore the cosmos, it also forces us to ask, if we are alone, what does that mean for our future? Are we destined to remain a solitary beacon of life, Or could we one day find others who share our extraordinary story? What if the reason we haven't found extraterrestrial life isn't because it doesn't exist, but because it's so advanced that we can't even comprehend it? This is the central question posed by the Kardashev Scale, a fascinating framework for classifying civilizations based on their ability to harness and control energy. Developed by Soviet astronomer Nikolai Kardashev in the 1960s, this scale invites us to imagine a universe filled with civilizations far beyond our own technological capabilities, some of which might be so powerful that they've reshaped entire galaxies. It's a concept that stretches the limits of our imagination and challenges us to rethink what it means to be an advanced species. At the bottom of the Kardashev Scale is a Type I civilization, which has mastered the ability to harness all the energy available on its home planet. For context, humanity isn't even there yet. We're currently considered a Type 0 civilization, still relying heavily on fossil fuels and struggling to tap into renewable energy sources efficiently. But a Type I civilization, think of a society that has complete control over its planet's resources, harnessing solar, wind, geothermal, and even tidal energy to power its cities, industries, and technologies. They'd essentially be the ultimate stewards of their world, capable of preventing natural disasters, stabilizing climates, and eradicating resource scarcity. It's a level of advancement that feels almost within our grasp, but still tantalizingly out of reach. Now, let's take a giant leap forward to a Type Roman II civilization, one that has moved beyond planetary energy and learned to harness the power of an entire star. Imagine building a megastructure like a Dyson sphere, a theoretical construct that encircles a star, capturing its energy output to fuel the needs of an unimaginably advanced society. Such a civilization wouldn't just be playing with fire, they'd be bending the very forces of nature to their will. The sheer scale of their achievements would make our greatest technological feats look like child's play. But here's the kicker. If a Type Roman II civilization exists somewhere in the cosmos, we might not even recognize their creations. A Dyson sphere, for instance, could appear as a strange, flickering star to our telescopes, something we might dismiss as a natural phenomenon rather than evidence of an alien superpower. And then there's the pinnacle of the Kardashev Scale, a Type Roman III civilization capable of harnessing the energy of an entire galaxy. To put this into perspective, the Milky Way alone contains hundreds of billions of stars. A Type Roman III civilization wouldn't just visit other star systems, they'd control them, using technologies so advanced that they might as well be magic to us. They could construct interstellar highways, manipulate black holes, or even create new stars. The question is, if such beings exist, why haven't we seen them? One possibility is that they've transcended the need for physical interaction, existing in forms we can't perceive or communicate with. Another is that they're so far beyond us that we're simply irrelevant to their grand cosmic plans. The Kardashev Scale doesn't just help us imagine what advanced civilizations might look like, it also forces us to confront our own limitations. If a Type Roman III civilization exists, how would we even begin to detect them? Our current methods of searching for extraterrestrial life, like scanning for radio signals or looking for biosignatures on exoplanets, might be woefully inadequate. They could be communicating through quantum entanglement, traveling through wormholes, or existing in dimensions we can't access. The scale reminds us that the universe is full of possibilities we're only beginning to scratch the surface of. But perhaps the most profound implication of the Kardashev Scale is what it says about humanity's potential. If we survive long enough to overcome our current challenges, climate change, resource depletion, and the threat of self-destruction, we could one day climb the ladder ourselves. Imagine a future where humanity becomes a Type Roman II civilization, harnessing the power of our sun to explore the stars and beyond. or even a type Roman III civilization spreading across the galaxy and shaping the cosmos in ways we can barely fathom. The Kardashev Scale isn't just a tool for measuring alien civilizations, it's a roadmap for our own cosmic destiny. So, as we gaze up at the night sky, wondering if we're alone, the Kardashev Scale invites us to dream bigger. The universe might be filled with civilizations so advanced that they've become invisible to us, not because they're hiding, but because we're not yet capable of seeing them. And in that possibility lies a humbling truth: we're still at the very beginning of our journey. The cosmos is vast, mysterious, and full of wonders waiting to be discovered. The question isn't just whether we'll find others, it's whether we'll rise to the challenge of becoming the kind of civilization that others might one day look for. What if the universe isn't a place of open communication and collaboration, but a silent battleground where every civilization hides in fear? This is the unsettling premise of the Dark Forest Hypothesis, a theory that paints the cosmos as a vast, dangerous wilderness where survival depends on staying hidden. Imagine a forest so dark and dense that every creature within it knows the rules. Make a sound, and you risk becoming someone else's prey. In this scenario, advanced civilizations might choose silence not out of indifference but as a strategy to avoid annihilation. It's a chilling idea that forces us to reconsider our assumptions about the search for extraterrestrial life and the risks of reaching out. The Dark Forest Hypothesis takes its name from Liu Cixin's science fiction novel The Dark Forest, but its roots go much deeper. At its core, the theory is built on two key assumptions. First, that the universe is filled with civilizations at varying levels of technological advancement, some far more powerful than others. And second, that these civilizations are inherently distrustful of one another, driven by the fear that any encounter could lead to conflict or even extinction. In such a universe, the safest course of action isn't to broadcast your existence, but to remain invisible, watching and waiting from the shadows. But why would civilizations default to such a grim outlook? One reason is the sheer unpredictability of first contact. If a civilization encounters another that's more advanced, they risk being exploited, enslaved, or destroyed. Even if both civilizations are peaceful, the fear of misunderstanding or miscalculation could lead to catastrophic outcomes. Think of it like two strangers meeting in the dark. Without trust, violence becomes a real possibility. In the cosmic context, the stakes are infinitely higher, with entire civilizations on the line. The Dark Forest Hypothesis suggests that silence isn't just a choice, it's a survival mechanism. This theory also raises profound questions about our own efforts to find extraterrestrial life. For decades, humanity has been sending messages into the void, from the famous Arecibo message to the signals broadcast by SETI. But what if these attempts are not just futile but dangerous? If the Dark Forest Hypothesis is correct, we might be inadvertently putting ourselves at risk, signaling our presence to civilizations that could see us as a threat. It's a sobering thought that challenges the optimism behind our search for connection and forces us to weigh the potential consequences of reaching out. The idea of a cosmic arms race adds another layer of complexity to this theory. If civilizations are constantly on guard, fearing discovery, they might invest heavily in technologies designed to hide or defend themselves. Some theorists speculate that advanced species could develop weapons capable of destroying entire star systems, using them as a deterrent or a preemptive strike against perceived threats. In this scenario, the universe becomes a place of perpetual tension, where trust is a liability and survival depends on secrecy. It's a far cry from the hopeful visions of interstellar cooperation that science fiction often portrays. Yet, not everyone agrees with this bleak interpretation of the cosmos. Critics argue that the Dark Forest Hypothesis assumes all civilizations are inherently hostile. a projection of humanity's own history of conflict onto the rest of the universe. They point out that advanced civilizations might have evolved beyond the need for violence, finding ways to coexist peacefully or even collaborate across the stars. Others suggest that the sheer vastness of space makes conflict between civilizations unlikely, as the distances involved would make warfare impractical. These counterarguments remind us that the dark forest hypothesis is just one way to interpret the silence of the cosmos, and that the truth might be far more nuanced. Ultimately, the dark forest hypothesis doesn't just challenge our search for extraterrestrial life, it challenges our understanding of the universe itself. Is the cosmos a place of cooperation and connection, or a dangerous wilderness where survival depends on secrecy? If the answer is the latter, then humanity's efforts to reach out might be more perilous than we realize. But if the answer is the former, then the silence we hear might not be a warning. It could be an invitation waiting for us to find the right way to respond. Either way, this theory forces us to confront the profound uncertainties of our place in the universe and the choices we make as we explore it. What if everything we see, every star, every planet, every living being, is just one tiny fragment of an unimaginably vast cosmic tapestry? This is the mind-expanding idea behind the multiverse theory, a concept that suggests our universe might be just one of countless others, each with its own unique set of physical laws and possibilities. Imagine a cosmic kaleidoscope where every twist and turn creates a new reality, some eerily similar to our own and others so alien that they defy comprehension. In this framework, the search for extraterrestrial life takes on a whole new dimension, stretching beyond the limits of our universe and into realms we can scarcely imagine. The multiverse theory isn't just science fiction, it's rooted in serious scientific inquiry. One of its foundations lies in quantum mechanics, the branch of physics that explores the behavior of particles at the smallest scales. According to the many worlds interpretation of quantum mechanics, every time a particle makes a choice, like which path to take in an experiment, the universe splits into multiple versions, each reflecting a different outcome. Over time, these branching paths could create an infinite number of parallel realities, each one a slightly or vastly different version of our own. In some of these universes, life might have evolved in ways we can't even begin to understand, shaped by entirely different laws of physics. String theory, another pillar of the multiverse concept, takes this idea even further. It proposes that the fundamental building blocks of the universe aren't particles but tiny, vibrating strings, and that these strings exist in multiple dimensions beyond the three we experience. Some versions of string theory suggest that these extra dimensions could contain entire universes, each with its own unique properties. Picture a cosmic library where every book represents a different universe, each one written in a language we've yet to decode. In some of these books, life might thrive under conditions that would be impossible in our own universe, from worlds with stronger gravity to realities where time flows backward. But what does this mean for the search for extraterrestrial life? If the multiverse exists, then life could take forms we've never dreamed of, shaped by environments and rules that are completely foreign to us. Imagine a universe where the speed of light isn't a limit, allowing civilizations to travel vast distances in the blink of an eye. Or a reality where life doesn't rely on carbon and water, but on entirely different chemical building blocks. The possibilities are as endless as the multiverse itself, challenging us to rethink what life could look like, and where it might exist. Of course, not everyone is convinced. Critics argue that the multiverse theory is currently untestable, a tantalizing idea that lacks concrete evidence. Without a way to observe or interact with other universes, some scientists view it as more philosophy than science. But even if the multiverse remains speculative, it serves as a powerful reminder of how much we still don't know about the cosmos. It pushes us to think beyond the boundaries of our own reality and consider that the universe or universes might be far stranger and more wondrous than we've ever imagined. At its core, the multiverse theory isn't just about parallel realities, it's about possibility. It invites us to consider that life might not be confined to the narrow conditions of our universe, but could exist in forms and places we can't yet comprehend. As we continue to explore the mysteries of the cosmos, this theory reminds us that the search for extraterrestrial life is as much about expanding our imagination as it is about discovering new worlds. The multiverse challenges us to dream bigger, to look beyond the stars and ask, what lies beyond the boundaries of our own reality? And in that question lies the true beauty of the unknown. What if the stories passed down through generations, tales of gods descending from the heavens, aren't myths at all, but records of real encounters with extraterrestrial beings? This is the provocative question at the heart of the ancient astronaut hypothesis, a theory that suggests humanity's past might be intertwined with visitors from beyond our world. From the towering pyramids of Egypt to the intricate carvings of ancient Sumer, this idea challenges us to reconsider the origins of human civilization and the possibility that we were guided or even shaped by beings not of this earth. Let's start with the evidence that fuels this theory. Take the Great Pyramid of Giza, for example. This monumental structure, built over 4,000 years ago, is a marvel of engineering that continues to baffle experts. How did an ancient civilization without modern tools or technology manage to align the pyramid so precisely with the stars, or move massive stone blocks weighing several tons with such precision? Proponents of the ancient astronaut hypothesis argue that such feats might have required knowledge or assistance from a more advanced source. Could the pyramids be more than tombs or monuments? Could they be evidence of extraterrestrial influence, a way for ancient beings to leave their mark on our planet? Then there are the ancient texts and artifacts that seem to hint at otherworldly encounters. In the Indian epic, the Mahabharata, there are descriptions of flying machines called vimanas, which some interpret as evidence of advanced alien technology. Similarly, the Sumerian tablets speak of the Anunnaki, a race of gods who supposedly came to Earth from the heavens. These beings, according to the texts, shared knowledge with humanity, teaching them agriculture, mathematics, and even the foundations of civilization. Could these gods have been extraterrestrial visitors mistaken for divine beings by ancient cultures? It's a compelling idea that blurs the line between myth and history. But the ancient astronaut hypothesis doesn't stop at artifacts and texts. It also looks at the sudden leaps in human development that seem to defy explanation. For much of human history, progress was slow and incremental until suddenly, around 10,000 years ago, something changed. Agriculture emerged, cities were built, and complex societies began to form. What caused this rapid shift? Some theorists argue that it wasn't just evolution or environmental factors, but intervention from an advanced civilization. If aliens visited Earth during this pivotal period, could they have accelerated our development, giving us the tools and knowledge to build the foundations of modern society? Of course, not everyone is convinced. Critics of the ancient astronaut hypothesis point out that attributing human achievements to extraterrestrials undermines the ingenuity and resourcefulness of ancient cultures. They argue that the pyramids, for example, are a testament to human creativity and perseverance, not proof of alien intervention. Similarly, the stories of gods and flying machines could be symbolic or metaphorical, not literal accounts of extraterrestrial contact. These perspectives remind us that the past is often open to interpretation, and that what seems mysterious might have a more grounded explanation. Still, The ancient astronaut hypothesis raises fascinating questions about the intersection of myth, history, and science. What if the stories we've dismissed as folklore are actually clues to a deeper truth? What if humanity's greatest achievements were inspired, or even assisted by beings from beyond our world? This theory invites us to look at our past with fresh eyes, exploring the possibility that our ancestors weren't just looking up at the stars in wonder, but interacting with them in ways we're only beginning to understand. At its core, the ancient astronaut hypothesis isn't just about aliens, it's about us. It challenges us to rethink our origins, our history, and our place in the cosmos. Were we alone in our journey to civilization, or did we have help from the stars? As we continue to explore the mysteries of our past, this theory reminds us that the truth might be stranger and more extraordinary than we ever imagined. And in that possibility lies a profound question. If we were visited once, could it happen again? The answers, like the stars above, remain just out of reach, but the search for them continues to inspire and captivate us all. What if life isn't just something that exists on a planet, but is the planet itself? This is the radical idea at the heart of the Gaia Hypothesis, a theory that reimagines Earth not as a passive rock orbiting the Sun, but as a living, breathing organism. Named after Gaia, the ancient Greek goddess of the Earth, this hypothesis proposes that our planet's biosphere, atmosphere, oceans, and geology interact in ways that maintain the delicate balance necessary for life to thrive. It's a concept that doesn't just challenge our understanding of life, it transforms it, suggesting that life might exist on a scale far grander than we've ever imagined. At its core, the Gaia Hypothesis is about interconnectedness. Think of Earth as a vast, intricate network where every component from the tiniest microbe to the largest ocean plays a role in sustaining the whole. Take the planet's temperature, for example. Despite fluctuations in solar radiation and other external factors, Earth's climate has remained relatively stable for billions of years, allowing life to flourish. How is this possible? According to the Gaia Hypothesis, it's because Earth's living systems actively regulate conditions like temperature, atmospheric composition, and even ocean salinity. It's as if the planet has a kind of immune system, constantly adjusting to keep itself healthy and balanced. One of the most compelling examples of this self-regulation is the role of plants in maintaining Earth's atmosphere. Through photosynthesis, plants absorb carbon dioxide and release oxygen, creating the air we breathe. But it's not a one-way process. When carbon dioxide levels rise, plants grow more vigorously, pulling more of the gas out of the atmosphere and helping to cool the planet. This feedback loop is just one of many that suggest Earth isn't just a stage for life. It's an active participant in its own survival. It's a perspective that blurs the line between living and non-living, inviting us to see the planet as a single, unified entity. But what does this mean for the search for extraterrestrial life? If Earth is a living organism, could other planets also possess this quality? Imagine a distant world where the entire ecosystem works in harmony to sustain life, not just in isolated pockets but across the entire planet. Such a world might not have recognizable life forms like plants or animals, but it could still be alive in its own way, with planetary scale processes that maintain stability and support complex systems. This idea expands the definition of life, suggesting that it might not always take the forms we expect. Critics of the Gaia Hypothesis argue that it leans too heavily on metaphor, equating Earth's systems to those of a living being without providing concrete evidence. They point out that while Earth's systems are undoubtedly interconnected, this doesn't necessarily mean the planet is alive in the way we understand life. Others worry that the theory could discourage environmental action, creating the false impression that Earth can always heal itself without human intervention. These concerns highlight the importance of viewing the Gaia hypothesis not as a definitive truth, but as a thought-provoking framework that challenges us to think differently about our planet. Yet, even as a metaphor, the Gaia hypothesis has profound implications. It reminds us that Earth's systems are deeply intertwined and that our actions as a species have ripple effects across the entire planet. If we see Earth as a living organism, it becomes harder to ignore the damage we're causing and easier to understand the urgent need for stewardship. This perspective also opens the door to new ways of thinking about life beyond Earth. If a planet can be alive, then the search for extraterrestrial life might not just be about finding microbes or intelligent beings. It could also be about discovering worlds that are alive in their own unique way. In the end, the Gaia hypothesis doesn't just redefine our understanding of life. It redefines our relationship with the planet we call home. It invites us to see Earth not as a resource to be exploited, but as a complex, dynamic system that sustains us. And as we explore the cosmos, it challenges us to ask, what does it mean to be alive? Is life something that happens on a planet, or is it something the planet itself can embody? These questions don't just expand our search for extraterrestrial life, they deepen our connection to the world beneath our feet, reminding us that we're part of something far greater than ourselves. As we reach the end of our journey through these 10 mind-altering theories, one truth stands out above all. The universe is a place of endless mystery and possibility. Each idea we've explored, from the ancient whispers of extraterrestrial visitors to the haunting silence of the dark forest, invites us to expand our understanding of what life could be and where it might exist. These theories don't just challenge our assumptions, they ignite our curiosity, pushing us to question the very fabric of reality and our place within it. The search for extraterrestrial life is about more than finding answers. It's about the questions we ask along the way. What does it mean to be alive? Are we alone in the cosmos, or is the universe brimming with beings so different from us that they defy imagination? These questions remind us that the journey of discovery is just as important as the destination. Every theory, every hypothesis is a stepping stone toward a deeper understanding of the cosmos and ultimately ourselves. What's remarkable is how these ideas connect us, not just to the stars but to each other. Whether you're a seasoned space enthusiast or someone just beginning to explore these cosmic mysteries, the search for life beyond Earth is a shared adventure. It's a reminder that, in the grand scheme of the universe, we're all explorers, gazing up at the same sky and wondering what lies beyond. So, what do you think? Are we alone, or is the cosmos teeming with life waiting to be discovered? Perhaps the answer lies somewhere in the vast expanse between the stars, or maybe it's closer than we think, hidden in the stories of our past or the possibilities of our future. Whatever the truth may be, one thing is certain: the universe is full of wonders that will continue to captivate and inspire us for generations to come. Thank you for joining us on this cosmic journey. If these theories sparked your imagination, let us know in the comments below which idea resonated with you the most. Don't forget to subscribe and hit the notification bell so you never miss an adventure into the mysteries of the universe. Until next time, keep your eyes on the stars and your mind open to the infinite possibilities that await. The cosmos is calling. Will you answer?